This is linear algebra. We're gonna talk about dimension of vector space. So previous video we talked about what is base, how can find the base. So let's talk about what is the dimension of vector space. Let's talk about dimension. What is dimension? Dimension is gonna be, let's talk about here. V is vector space spanned by the finite set. So which meaning is some vectors spanned by number of vectors. So that case, we're gonna be finite dimension. You're gonna write down dimension V, guys, dimension V gonna be number of vector in a base. So you find the base for vector space, count them, okay? How many vector there? That we call dimension. For example, standard base R2. R2 we talk about what is the standard base R2 gonna be? 0 and 1 and 0. That's gonna standard base for R2. So what is the dimension of R2? The dimension of R2 gonna be 2 because how many elements in the base? 1 and 2. Guys, make sense? Okay, that's how to define the dimension of the vector space V. So, very special case, zero vector. Only have vector space have zero. That case looks like element is one, but we're gonna say dimension of zero vector space gonna be zero. That's we specially define vector space, dimension of vector space in zero. Zero vector space gonna be zero, guys. So another thing is you have very carefully understand infinite dimensional, okay? So vector space is a span. It's not spanned by finite set. So vector in the base is infinity. We're gonna say infinite dimensional, okay? So very good example of infinite dimension is R is you are gonna be is set of all polynomial with all different degree. That case, so what is based of about this set or the set of all the polynomial with any degree? That's gonna be 1 t squared, t third, and tn plus 1. You keep going. So that case is gonna be dimension of P is infinity. All right. So let's go to more there, guys. Okay. So let's find dimension of R3. What do you have find it, guys? First, you're thinking about what is base for R3. Okay. So we find the base of R3. Standard base gonna be we did 1 0 0 0 1 0 0 0 1. Just quick remind, guys, the base meaning is this set gonna be span R3. Span means linear combination of these three vector in the all vector in R3. That's the first. And second is this should be linearly independent, right? Independent. So how many elements here in the base? That's 1, 2, 3. So dimension of R3 gonna be 3. So can you see something here, guys? R3 here is number 3. That's the dimension of R3. Very clearly, you're gonna find the dimension of R3, guys. So you're gonna generalize what is the dimension of Rn. So you're gonna find standard base for Rn, that's gonna be n vector, okay? Let's do the second one. P2 is gonna be, guys, remember what is P2? You're gonna correct all the polynomial with degree 2. What element in here? Let's say here is 1 plus t squared. That's gonna be here, P2, polynomial with degree 2. So we find the base of this P2. What is base? Guys, remember 1 t squared. That's the base for polynomial with degree 2. So what is the dimension of P2? How many elements? 1, 2, 3. That's going to be 3. So whenever we're talking about dimension, guys, you have to thinking about what is base for the vector space. That's the main concept over here, guys. Next slide, I give H vector space span 2 vector, V1, V2. V1 is 103, V2 gonna be 316, guys, here, right there. This all vector is R3, this is R3. Why? This is 3 entries right there. So we wanna find dimension of H, guys. So we already know H is span V1, V2. So what I have to show that we have to show V1 vector, V2 vector gonna be linearly independent. That's we have to show it. Okay, guys? Okay. How can you show this is linearly independent, guys? Okay. So look at this V1 vector, 103, V2 vector, 316. Does Kaplan way show these two vectors linearly independent? But very easily show is you cannot say here, guys, you can put V1 is K, scalar multiplication V2, it's possible, or V2 gonna be scalar multiplication of V1. Can you find the K value? Okay, first one 3, right there is V1. Let's say this, check this one, guys. V2 is a 3, here is 1, so oh, my K is a 3. Then what happened? Here is, let's say your K is a 3, that case, guys. Look at this one. Okay, say 103, you put the 3, that's gonna be 309. This one is a V2. Yes or no? No, no. So this one is, you cannot write V2 is multiple of V1, which meaning is, we're gonna say, guys, this one is V1, V2 is linearly independent. Okay? So now we're gonna conclude V1, V2 vector is a base for H. So how many elements here? Dimension of this H, because we find the base for the vector space H. How many? Factors, 2. So dimension of H is 2, guys. Okay, make sense, guys? Okay, that's how to find dimension. So keep in mind you're gonna find base for the vector space. That's how to define the dimension. Another example, guys, look at this one. We're gonna find the vector space of H. That's gonna be element of vector space H. We want to find the dimension. So guys, what you have to check is find the base for H. That you have to do it. So let's rewrite this element in the H, vector in the H. So let's write it. Base meaning is what? You have to check two things. What kind of vector span the H, and that vector gonna be linearly independent. So, okay, let's first check it. Okay, this one is linearly combination of what vector? So we already practiced a lot, guys. Here is A. So here is A. Here is A. No A. So you have first vector gonna be 1, 5, 0. Everyone make sense? No 0 here, okay? So 0A here, you're gonna write it. Okay, second part, you're gonna see here is B. Here is B. No B here. So you're gonna have B 201. Guys, make sense? Third one, here is a C. No C is the first one. So C is a 0. Second is 10. Third is -1. You need one more. D gonna be -3, -5, -1. So you gonna this vector in the H, you have a linear combination, right? So what do you find here, guys? Look at this one. Let's say this one is V1 vector. This is V2 vector. This is V3 vector. This is V4 vector. Right? So this vector in H, all right, so you're gonna write this way. Vector in H is H gonna be span with the 4 vector. Find it. V1 vector, v2 vector, v3 vector, v4 vector. So that's your first find date, guys, okay? So that's the first part. Second part, what you have to prove is, second is, first H gonna be span 4 vectors. Second is we have to show this one is gonna be linearly independent or not. Okay, previous chapter we have a lot of theorem to show this 4 vector is linearly independent or not. So first we have to make the metric, guys. Here is a metric. Then we're gonna row reduce to the row Angela form. That's what you're gonna do it, guys. Okay, let's do this one. 1, 5, 0, 2, 0, 1, 0, 10, -1. I need more space, guys, here. Last vector gonna be -3, -5, -1. Okay, so we're gonna do row operation, guys. You're gonna do row operation and change it to the row Angela form. Okay, let's do the first one. Here is what is gonna be, here is the pivot. You're gonna make this one 0. So I'm gonna go a little quickly, guys. R1 plus R2 go to R2, right? So I have this one. 1, 2, 0, -3, 0, -10, 10, 10. Third one is 0, 1, -1, -1. Okay. Second part, what do you have to do? So this one is a pivot, right? This one is a pivot. So you divide by -10, right? So this one -1/10, R2 go to R2. So you have 1, 2, 0, -3, 0, 1, -1, -1, 0, 1, -1, -1. Guys, make sense? So this one is gonna be make 0. You have to -1 R2 plus R3 going to R3. So you have 1, 2, 0, -3, 0, 1, -1, -1, 0, 0, 0, 0. Okay? So I'm gonna do reduce row Angela form. So what is gonna be next one? You see this one? Right, guys, this one. So let's do that one. Let's make the 0, right? One more thing. Reduce row Angela form is much easier to figure it out. This vector gonna be linearly independent or dependent. Okay, what do you have to do? So -2 R2 plus R1 go to R1. So I have this one, guys. 1. What do you have? 0, 2, -1, 0, 1, -1, -1, 0, 0, 0, 0. So you have different way figured it out, guys, okay? So this REF, the reduced Angela form, where is the pivot? What is the pivot column, guys? One theorem say this is pivot column, this is pivot column. Everything makes sense? So which vector gonna be linearly independent? So column 3, column 4 is not pivot column, right? So you have this one is first one, second is gonna be linearly independent. So go back to original the matrix. So you're gonna say this one is gonna be linearly independent, guys, okay? So we're gonna say V1, V2 gonna be linearly independent. So what is gonna be base, their case? V1, V2 gonna be base for H. So dimension of H gonna be how many vector in the base? 2. So 4 vector is span the vector space H, but other 2 gonna be linear combination of V1, V2. So now 4 vector, base gonna be V1, V2. That's the base. Dimension gonna be 2, guys. Okay?